All right, so number 2 is identifying each of the following functions as linear, quadratic, or exponential. So just to refresh your memory, anything that is linear is going to have common first differences, quadratics have common second differences, and exponentials have a common ratio. So first, second differences doesn't work. See if you can multiply by something or by a factor to get the next in the table. So starting with h of x here, I noticed that from 200 to 220, it goes up by 20, so plus 20. And from here, it's plus 20 again. And from here to here, it's plus 20 again. So if all of those are the same, the first differences are the same, then this one is going to be linear. Looking over at j of x, I noticed that this goes up by 100. The next goes up by 120, and then the next goes up by 144. So 144. So obviously the first differences are not the same. So now I move on to test the second differences. So from 100 to 120 is a positive 20 change, and from 120 to 144 is a positive 24. So the second differences are also not the same. So if that doesn't work, the first and second differences do not work, then you need to try to find a common ratio. So take the second number in your table and divide it by the first. So 600 divided by 500. That gives you a ratio, or a times 1.2. Then I take 720 and I divide it by 600 to see what is being multiplied there. And that is being multiplied by 1.2. And finally, 864 divided by 720. So this one divided by the previous one. And it turns out that all of these are being multiplied by 1.2. So if the first differences are not the same, the second differences are not the same, and the common ratio, which you're multiplying by, is all the same, then I can determine that j of x is an exponential function. All right, now looking on to f of x, now we have a little different situation here. We have a function instead of a table. We just have the function. Now you could plug this into your calculator and get yourself a table and kind of make yourself a table and do these, what we just did for the first two. But there are key characteristics of any function that kind of determine what it is or what kind of function it is. So for this one, I noticed that I have an exponent of 2. So an exponent of 2 is a dead giveaway. So anytime you have an exponent of 2, and especially if you have 3 terms with an exponent of 2, that means that this is a quadratic. And if you plug it into your calculator and you were to see the graph, you would see that the graph is a parabola, and which means that that is a quadratic graph. So I'll plug it in real quick just to show what I mean. So 3x squared plus 5x plus 3, and then I just hit graph. Gives me a U-shaped, a positive parabola with a minimum point. But any parabola graph is going to be also a quadratic graph. And then finally, g of x. G of x again is in a formula, or in a function format, or function notation. Not a table. So we're looking for key features of the function and to kind of indicate what we're dealing with here. So I notice again we have an exponent, but this time the exponent is x. So whenever you have an exponent of x, it automatically becomes an exponential function. So an exponential function. Now you can plug this in and it'll give you an exponential function. I'm not going to do that just for the sake of time. So that is number 2.